Somebody very wise told me last week, Alan Alda, that a podium is a good thing to have for a lecturer because it provides some distance and some protection. So I'll make use of it. Well, thank you very much for the invitation. I think it's about time that such a symposium was set up. Why did it take you so long? So welcome everybody, welcome especially to our guests. I would like to begin by saying that we're here to discuss something which we arguably call one of the most important advancements in computer-aided design. In fact, the name of the symposium refers to it as a revolution. I would like to claim, I'm not going to argue whether it is or it isn't, but I'm going to claim that this revolution has been in the making for almost 50 years. So it's a kind of a slow revolution that has been going on. In fact, the first paper on this topic was published by Chuck Eastman and his students from Carnegie Mellon in 1974. That was the first time that a paper talking about building description system, BDS, was published. A couple of years later, they published another paper. Chuck and Max Henrion, whom I'm sure you remember, published a paper called GLIDE, Graphical Language for Interactive Design. And that was a system that at least two of us in the audience have worked on, Kobiaski and I, when we were students in Chuck's lab, which was a language to actually do what BIM is doing today, to make a system that can describe physical objects with all kinds of details, enable editing those entities, query the database in different ways. And that was the first, as far as I know, implementation of one of these things. The term building information model, or building model, first came out in 1985. It was a paper by Simon Ruffle and Robert Eisch that many of the in the audience probably know. He worked on a system called RUCAPS, which stood for Really Universal Computer-Aided Production System. But it was one of the first ones to implement something like akin to BIM. The term BIM itself only started out in 1992, also in a paper, and became popular in 2002 when Autodesk picked it up and started to use it for its products. Other companies like Bentley Systems and Graphisoft did the same, so the term has become recognized and popular, and that's what we use today. The question is, okay, here we are almost 50 years after the introduction of this concept. Where do we go from here? What's in the future? And I would like to claim that there are still things to do. We're not done yet as far as BIM is concerned. The major advantage of BIM has been the ability to describe the physical properties of the building, of the object that we call a building. But there are other properties that are needed when we want to analyze and evaluate the building, as we all do. So what else is necessary in order to be able to do that? There are many components that are outside the database, outside BIM, like energy, which has its own models, but they need to find information on which to operate within the building model. And some of that information is still missing. The ability that computers have had since the beginning of this concept, 50 years, have changed tremendously. So we can do things that we could not do 50 years ago or 48 years ago in terms of the kind of information that we can represent and we can use. For instance, we can now represent not only the physical components of the buildings, but also some of the things that are happening in them or are supposed to happen inside those components. What are they used for? Who is using them? In what ways? We need to develop models that will describe those things, but we also need to embed in the building model those pieces of data that will allow the outside simulations and other methods to operate on the data. They will not have to be added individually. Because one of the concepts of BIM was to provide a single database for all stakeholders. So they will not add superfluous information of their own, which may be different than somebody else had added, and then it's a different building. So if we want to evaluate buildings for properties that are universal to that building and should be shared by all stakeholders, they have to be part of the model. And some of these things include things about the function of the building. What is it? A hospital is not like a high school. It's a different kind of a building, even if it is made of rooms and walls and windows, just like the other one. And it will be used by different people than the one in the first example. For instance, a school may be used in the morning by children who have certain needs, and in the afternoon it may be used as a community center and by adults or even elderly and have totally different needs. So is the building that was designed appropriate for their use, and what are the differences? Even if you consider as something as simple as the bathrooms or the furniture or the connections between the rooms or which room is most important, we need to know that, and that information has to be part of the building model because it is part of the model. So these are the things that I think we will have to work on in the future. And since these things are not physical, they can be dynamic. They can change, like the use of the building. It can be a different building in the morning, a different building in the afternoon. It's the same building, but it's a different building because it's used differently by different people, and it needs to answer the needs of all these populations. That's kind of a dynamic data that has to be added somehow to the building model in order to make it useful for other things. So, for instance, who are the main users of the building can be part of the model. What are their main activities can be part of the model. How much time do they use the building or parts of the building? What kind of consequences are to their users? Do they make noise? Do they generate heat? What are the main points of interest? Where will people want to go in the building? It may be a different focal point in the morning, a different focal point in the afternoon. You know that from train stations that the traffic is reversed and you have different flows at different times of the day. That all can be and should be part of the model. I'm not going to tell you how to do that. We have a research team here at the Technion working on such things, my group, under a project which we call Next Generation BIM, Next Gen BIM, nicely funded by the European Research Council and by the Israeli Science Foundation. And we are producing additions or enhancements to BIM along with the simulations that use them, so we can test if the information is adequate and if the model can use it in order to be able to look forward and see where BIM could go in the next few years. So thank you very much, and an enjoyable symposium to all of us, and thank you for the guests for coming all the way to help us. Thank you.